Hello! Testing, testing. Yes, I didn't really play them as they came out, the expansions for Civ 4, so I can't give you, like, what the relative strengths of each of them are. However, I would say with the with the Beyond the Sword expansion, if you go into the mods, there are a couple of really interesting modes, one of which is, just it makes the Civ 4 kind of like Stellaris, and it's like wonderful. You like build colonizations on star systems and expand out that way. It's really really good. Uh, yeah, I've never played the board game, so uh, the colonization one is interesting, but tedious. I found it tedious. And like nearly impossible to actually win even on easier difficulties, which it's fine, but who wants to put 20 hours into a game only to be inevitably crushed by the European colonial or the European imperial power? But anyway. Also, I don't know. I find it interesting, the Civ colonization game, Civ 4 colonization, because it's a very, very American perspective. Basically, your object is to become the United States of America, and being a person who lives in Canada, and being a person who realizes that peaceful secession from the British Empire was not only possible, but in fact a thing that we did as a nation. The idea that there's only one path to victory, and that is to become the United States of America. It's a very American perspective on the whole thing. But at any rate, we should probably talk about programming. I have not played Anno. That might be interesting. Yeah, I love me my 4X games. I love me my 4X games. Actually, lately I've been playing Sid Meier's Alpha Centauri, which is a Civ 2 mod. But, man, go to Good Old Games. It's, dirt cheap. Get Sid Meier's Alpha Centauri. That thing is... It is one of the best strategy games that's ever been made. But only because I am a person... In my particular orientation is I like, pedantic philosophy to be quoted at me during a game, and that game is full of pedantic philosophy. But anyway. Yep. Settlers on Steroids probably does it justice. But anyway, so let's talk about programming today. So, we were talking about statements. We had just gotten into for loops. We'd done a couple of examples of for loops, but we hadn't really gotten into it in a great deal of detail. There's a few slides in here that sort of riff on the idea of for loops for a while. So just in summary, for loops are extremely helpful. Get it, topic 3.py. It's kind of like in Python, there's a much greater distinction between for loops and while loops than there is in other languages. In other languages, a for loop looks like this. You would have for int I equals 0, I is less than 10, I plus plus being the same thing as plus equals 1. Basically, it's doing all of the things that a while loop does, just all in one line. So, hypothetically speaking, you wouldn't be able to... Oh my gosh. Get out of here. Why am I getting these notifications? Do I have something open in a different workspace? My goodness. My goodness! Why is it happening? I don't see anything open. I don't see why that should be happening. Get out of here. Weird. Anyway. Yeah. So in other languages, it's basically just more compact while loop notation that kind of theoretically since everything's in one place, it's harder to forget to increment the loop counter or something like that. In Python, the for loop is an entirely different thing. It is a horse of a different color. In Python, a for loop requires an underlying data set. You need to operate the loop over top of a string or a tuple or a dictionary or a list or a set, some kind of iterable data structure. In C#, the equivalent is a for each loop. So there are equivalents of this in other languages, but in Python, it's just a for loop. So you plug your data structure, whatever that may be, in the second slot. And in the first slot, you designate a name that you wish each of the elements of the data structure to be called for the particular iteration of the loop that you are in at that particular point in time. So this example that I've got here, we've got the string hello world. We have for character in hello world, print that character. Since print does a new line each time, if we take a look at, I think I got the output here somewhere. Yeah, here it is. Hello world, each character gets printed out on its own line. This is exactly equivalent to this particular formulation in while loops. However, you can see that what a for loop does in 2 lines, a while loop takes 6 lines to do. And with a while loop, and unless you get all of those 6 lines correct, basically you're at risk of creating an infinite loop, which is, generally speaking, a situation that you wish to avoid at all costs and in all manners possible. So, generally speaking, when you can use a for loop, you should use a for loop. That's your takeaway. In fact, by the end of this course, using for loops is going to be so, second nature to you, then, I will have to write a question specifically to use a while loop instead of a for loop if I'm trying to test while loops. Let me see if there are any questions. My camera froze again. Oh my goodness. Boop, 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 boop. Oh, that's a funny face to get stuck on, too. My goodness. All right. Why? Why do you switch to that? Who knows? There we go. There we go. Testing. Nope. Still not it. Sorry about this, folks. I don't know why it does this. There we go. Back to the condenser mic. Barp, 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 barp. Is there a scenario where we can't use a for loop for something? No. And we're gonna see why. So, well, actually, I'll take that back. The interesting thing about a while loop is that you can do some pretty exotic conditions with it. Because with a while loop, you're not limited to doing something numeric or something over a, particular, set of numbers. The condition is much more general, right? So let me give you an example of something that involves inputs. This is something you can only do with a while loop. So get out of here, you. There we go. So response is equal to input. Enter the number 5. If response, while response does not equal 5, print you dummy I told you to enter the number 5. And then if you copy this, there you go. Copy that in. If you execute this program now, Python 3 topic3.py, no such topic3.py, there we go. Enter the number 5. No. You dummy, I told you to enter the number 5. No. No, 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 no. 5. And you exit. So this is, you can set, so what this loop is doing is it waits until the like a while loop will wait until the condition is false and then it exits. So you can use that in a much more general way because conditions, Boolean conditions, are a much more general mechanism than iterating over the elements of a data structure. Even like if you're doing a numerical loop, like the factorial examples that we were doing earlier, it is possible to generate data structures on the fly that contain all the numbers you need, right? But it's not possible to use a for loop for this because, well, if you were sufficiently clever, you might be able to find a way to do this with a for loop. However, it's much, 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 much more natural to do this with a while loop, right? Because it sort of rests on the ability to do really crazy things with loop conditions. However, notice that the thing that we're testing is being updated each time the loop iterates. So in a regular loop, the loops we've seen so far, you would be updating like I or whatever the counter variable is. In this case, we are updating the response each time the loop iterates. That way you do have something that is hypothetically changing, right? The thing that you're testing for has to have the ability to change while the loop is executing, or else the loop will run forever, is basically the thing. So yeah, that's hopefully that's an interesting example. Cool. So, yeah. So that's an example. We already talked about potato example. So here is an example of using a for loop to do the types of numeric stuff that we've been doing with counters so far. So if we do a loop with a counter that goes from 0 to 10, or 0 to 9 in this case, there's no reason why we couldn't use a for loop to generate to do that. Let me rephrase. For loops are also capable of performing this type of operation. The requirement is that you generate a data structure on the fly that contains all of the numbers that I would be. Then you can for loop over those because you have generated an iterable data structure that contains all of the index numbers that you would want to use in a while loop. So let me show you how this works. First, I'll show you how the range function works. So range generates a series of numbers. So if I do range 10, it does a range from 0 to 10. Now, it returns a range object, so I'm just going to typecast it as a tuple so that we can see what's going on the inside. So when I say give me range 10, by default, that gives you from 0 to 9, right? So that gives you 10 elements. So it's and there are different ways of using this as well. If you specify two numbers, say from 5 to 15, again, casting it as a tuple, you'll notice that we start counting at whatever the first number is, and we stop counting at 1 minus whatever the second number is. So in this case, we've got a range that goes from 5 to 14. So if you wanted to generate a series of numbers that are the same thing as the same as all of the indexes that would be generated, through the execution of this while loop. This is that is how you would do it. From an efficiency standpoint, this is less efficient than a while loop because you're generating a whole extra data structure to hold all of these numbers, whereas with a while loop, you're just updating the same piece of memory multiple times, which means that you don't need as much memory. However, in practical terms, the amount of memory that you would consume by performing this sort of operation is infinitesimal compared to the memory that you probably have available in your system. So, people haven't really had to worry about this type of memory allocation since the amount of memory your system had was measured in kilobytes, which used to be the case. I remember way back in the day, I used to have a compact Presario, which was a 486, that had, something like 64 kilobytes of RAM, which was a lot. It was a good computer when it was purchased. So, yeah. So anyway, the range object can be used to generate ranges of numbers, and those can be iterated over for the purposes of using a for loop. And you don't even have to assign the thing to an intermediate variable. You can just directly pop that right in the for loop. So there's another... Okay, so... But, Mr. Professor, sir, what if I don't want to count by ones? What if I want to count by twos? Or what if I want to count backwards? Check this out. If you want to count by twos, you can specify a third argument. That is the number that you want to count by. So if you want to generate all the numbers from 100 to 10,000 and count by sevens, there are all of your numbers. Kablam! Number explosion. And I think this works. If you want to count, for example, from 0 to 10, if you want to count from 10 to 0, count backwards from 10 to 0, I believe you can do that like this. Yes! Cool. So, it's a little bit tricky. If you specify count from 10 to 0, it'll give you an empty tuple. You have to also specify that you're counting by -1. So you're counting down by 1 each time. That's, otherwise, it's otherwise the condition is kind of I'm going from 10 to 0. 10 is already greater than 0, therefore you want no numbers. Unless you specify that you're counting down by doing this right here, it won't give you what you expect. So some of the more observant of you may have noticed that the rules pertaining to the first, second, and third arguments of the range function are actually precisely the same rules as apply to the slicing operation. So, if I assign, I'm just going to generate a range here from 0 to 100. Cast t is equal to tuple t. There we go. So t, let's just imagine t is this tuple, right? If we slice it from, say, 6 to 76 by 3s, that's what we get. Range from 6 to 76 by 3, if we cast it as a tuple, you'll notice that that's actually the precise same thing, right? So the rules around how tuples are sliced, how strings are sliced, how lists are sliced, are the same rules as how you generate numbers with a range object. So there you go. Cool. So let me see. Do I have... Maybe I have chat activity, it's just not showing up. Nope. Okay. Alright. There we go. So in this particular instance, if for example, let's quickly do a factorial example inside of the interpreter. So def factorial, we're going to do factorial of n using for loops. For x in range from 1 to n plus 1, because remember, when you generate the range object, it excludes the upper bound, right? In the same way that list slicing does. So if you want that upper bound number to be included, you have to add 1. That's a common pitfall. But before I get there, I actually am going to have a product. Product is equal to 1 for x in range from 1 to n plus 1. Product equals product times x. Return product. There we go. So if we call factorial on 5, we should get 120. Right? Factorial of 1 is 1, 2 is 2, 3 is 6, 4 is 24, 5 is etc., etc., etc. So there you go. Make sense? If that makes sense, can I get a thumbs up? The body of the for loop should not modify the variable n, or you could get strange behavior. Yes. So that's a good point. So let's imagine for a moment that we were for looping over a string, right? For character in string, we'll do something like s is equal to s plus b, right? This is going to cause an infinite loop. Because the data structure is expanding at the same rate that it's being consumed by the for loop never catches up to the end of it. Therefore, does it work? That's interesting. It might be because it's a static data structure. If I were using a list, that would probably be different. I think it works with a list. Give me a second here. List for element in list. List is equal to list plus concatenated with 5. Really? Huh. That's interesting. Well, that didn't used to be the case. I don't know. Maybe they've built in, maybe the new version of Python has stuff built in to prevent you being able to do that. Anyway, I won't belabor the point then. The point is, you shouldn't modify the thing you're operating over as you're for looping over it. It's a bad idea in general. Range object, I've already talked about the range object quite in detail, but here it is again. It generates a sequence of numbers. You can use 1, 2, or 3 arguments. If you use 1 argument, it generates from 0 to n minus 1 when you provide n. If you provide 2 arguments, it generates it from a to b minus 1, stepping by 1. And if you provide something for step, then it starts at a, counts by step, and stops as soon as it hits z, where z is sort of the maximum one that's less than b. So, for example, in this version, when we generated from 100 to 10,000 by 7, you'll notice that this guy right here is, it's the maximum element that you get to by stepping that doesn't go over the upper bound. So it's kind of like Price is Right rules. As close to this number without going over as possible. I don't know. Does anybody Has anybody seen The Price is Right? Has that exited the cultural zeitgeist because people don't watch daytime television anymore? Tell me in chat. Do you guys does Price is Right still exist for you? Why don't you use the x plus 1? X plus equals 1. I don't know. I don't know what that refers to. Old people show. Meh. It was better when Bob Barker was on it. Never watched it, but Price is Right rules is a known. Okay, so if Price is Right rules is common knowledge, then I'm still okay. Okay, yeah, okay. Can you refer to every other item in a for loop as in every other in a string? Yeah, you can do one of two things. Like, you could keep a flag that, like, oscillates between true and false, and then only execute the body of the loop for, like, every other. Like, you can keep track of whether you're on even or odd iterations of the loop and just, you know, toggle code with if statements. I know it's Boomer TV. All TV is Boomer TV, except for Inspector Gadget. In the factorial function. Yes. That's the, okay. That's actually an important thing. So, the reason we don't have to do x plus equals 1 here is because x is going to be every element of the generated range. So, we don't have to worry about incrementing x, right? X is going to be this one, then it's that one, then it's that one, then it's that one, except, of course, it's going to be the ones that are, like, in this range rather than in this range, right? So we don't actually have to increment x. That's the whole thing. We don't have to increment x. The whole point of this is that we don't have to increment x. Yeah. Moment of silence for Alex Trebek. You know that guy was Canadian? Yeah. My goodness. Yeah, I'm just showing my age. That's okay, though. Cool. Yeah. Sometimes when I do the loop and try to include the final number, it'll tell me it's out of range when I do 1 to n plus 1. Weird. Because you shouldn't get an out of range error unless you're indexing it. So that can be okay. I can see a situation in which that would take place. So, that's wrong. Do I have this? Yes. So, for x in, for I in range length of t, print t at I. Or, no, that's... Come on, work with me. There. What? For I in range length t, print t at I. There you go. So, in this particular case, if you use a +1 there, then you'll get in trouble, right? Because the range of the length of t plus 1, because we're using 0 indexing, that's going to eventually get, like, you're going to test one more, you're going to have one more entry than there are actually things in the data structure. So if you're using this type of a construction to iterate over a loop using indexes, which I don't know why you would do this, it's more work in a for loop than just allowing this automatic assignment to be every element in the data structure rather than indexing them. But, you know, sometimes you need the loop indexes because you have to, like, look at the next element, you know? But in those types of situations, it might be better to use a loop anyway. But yeah, this will cause an error, but this will not, because when you are indexing over a data structure manually, you always have to be aware of the limitations of the size of that data structure. That's a very common type of error, actually. Good. Yes. So, yeah. Let's see if we can close off this topic today. There we go. So, range object, yes. We talked about that. Generates a series of numbers. They must be integers, however. That's the thing about the range object, is it only generates for integers. Yes, we kind of already did that. Linear search with for using range. So again, I don't know why you would do it this way instead of doing it this way. Def lin search sc for c2 in s if c is equal to c2, return true, return false. There you go. Lin search hello world, searching for L true, X false. There you go. So, see, the thing I don't get about all of this is I don't know why you would generate a range object, assign it to I, and then use I to index something, when if you just take this, plop it in here, then you get the indexing operation for free, and then you don't have to worry about screwing it up. But, and we already did factorial according to for loops. But this is how the slides say you should do it, which is pretty much the only major difference here is the existence of the times equals operator. I'll just show you what that does very quickly. So if x is equal to 5, x times equals 6, it means that x becomes 30. It's just shorthand for x is equal to x times, whatever. There are a bunch of these, actually. You got plus, minus, mod equals, division equals, multiplication equals, and I know in C you've also got bitwise operators. We haven't talked about bitwise operators, but you don't have to worry about them just yet. We'll get into them a bit when we talk about binary representations. So, some common errors in loops. These are important to know because these are common pitfalls. Incorrect initialization, particularly that of the accumulators. So in the factorial example, if we were to initialize f to 0, that would be an error. Because if f is 0, then anything multiplied by 0 is 0, so then this would always return 0 regardless of what the input is, which is not the correct functionality of the factorial function, right? So because it's multiplication, you have to initialize it to 1. Of course, so the thing is, if the way that you're learning to code is like, I'm going to memorize code templates, that is the wrong way to learn how to code. You should not be memorizing the code that is existing inside of these slides. What you should be doing is you should be learning the functions of all of the operators I'm discussing. You should learn what a for loop does. You should learn what a while loop does. You should learn what times equals does. You should learn what the range object does. And then you can take all of those pieces, put them together in an interesting and unique manner to solve math problems. That is how you program. If you go to write a while loop and you are like, I don't know what I'm going to do with this while loop, but I know that I need a while loop, So since I need a while loop, I'm going to add a counter and an accumulator automatically without even thinking what those things are even being used for. That's the wrong way to program. You're not thinking. You're merely you're doing programming like it's multiplication tables, and it's not like multiplication tables. It's you gotta use that squishy gray thing between your ears. So don't automatically declare variables you don't need. You know, if you do, if you're in that mindset, then you will have things that you think you should automatically declare variable or initialize variables with. So, like, if you're counting something, it makes a lot of sense to start your variable at 0. If you're taking a product of something, it makes a lot of sense for your variable to start at 1. But these are not the only two things that are possible. Like, you know, it's you could often be starting an accumulator at, like, an accumulator might be you're accumulating a list of things, in which case your list that you start off would be an empty data structure. Like, there are lots and lots of cases, and it's like, what you don't want to do is you don't want to automatically put stuff in and not understand how it relates or how it is going to be used in the particular context in which it's being used. Anyway, incorrect termination of loop condition. Normally, this means you used a less than equals instead of a less than or something like that. These are usually reasonably easy to pick out because you'll execute your loop and you'll get something like an indexing error, right? However, sometimes it can be a little more tricky. In the case of the factorial, if you're doing the factorial with the while loop, if you, if you get an off by 1, then your actual numerical value that you're looking for will be off. It will not match what the definition of the factorial says it should be, which is a little bit trickier to catch than it just spitting up a, it terminating your program because you tried to access a loop tried to access a tuple element that doesn't exist, for example. Infinite loops are a common error. Normally, they're caused by incorrectly updating the loop variable, although they can also be caused by bad Boolean conditions in your loop. It's actually, it's trivial to create an infinite loop. All you have to do is say while true, pass. And that's an infinite loop. Right? There's no way that true can be false, so there's no way that the while loop can terminate, so it's an infinite loop. Index calculations off by 1. That's a reasonably common one as well. Normally, it's caused by you guys still being stuck on the idea of 0 versus 1 indexing. Keep in mind, all data structures in Python start numbering things at 0, not 1. 0, 0, 0. Also, improper bracketing and indentation of nested loops is one. This will cause very strange errors that, you have no idea what the problem is. And the only real way of getting around that is practice. So here's a question. How many errors are there in this program, given that the function of this program is to count the number of instances of the letter N appearing in the string sequence? I will give you a moment. Enter your votes now on your handy vote tabulating machines, by which I mean the chat. And if any of you know what a problem is with this piece of code, please tell me that as well. Oh, I got a question as well. Yes. How would you compare two objects in a string or tuple that are consecutive? Okay, yeah, that's a good question. So, let's say you wanted to do exactly that. So, let's say you wanted to compare. Okay, we got this data structure. Let's say we want to compare it to see if any two adjacent elements are the same, and return true if that's the case. So I is equal to 0, while I is less than the length of t minus 1. The minus 1 is the important part. If t at I is equal to t at I plus 1, return, or let's say, in this case, print yes. And of course, the silly professor does the thing that he tells everybody not to do in forgetting to increment his loop variable. There you go. So it did not print yes, so none of these are the case. So basically, if you have to compare two things that are side by side, just reduce the maximum value here by 1, and then do I plus 1 there. There you go. So, couple of questions. Yeah. So first of all, less than or equals. That's correct. So this will cause an indexing error. That's 1. X is undefined. That's right. This has not been declared before it's used. X has not been declared before it's used. So this will also cause an error. That's 2. It's an infinite loop because this guy is it's at the wrong indentation level. He should be 1 indentation level shorter so that he's in line with the if statement. That's because we don't want to, the way that this code is written now, I equals I plus 1, this line will never be executed unless this condition is true. So, it's kind of funny, in this particular instance, it will only correctly count the number of n's if every single character in the entire loop is n. Because that's the only way that this guy will, as soon as it hits a character that's not n, it will fail to increment the counter variable, which means you're now stuck in an infinite loop. Yup. So there you go. Yep. So yeah, there you go. I think that's enough. Yeah, there you go. So that's 3. And very quickly, for loops versus while loops, a summary. For loops automatically initialize and increment the loop variable, thus avoiding certain classes of errors. For loops may necessitate jumps out of the loop by return or break statements, thus having multiple exit conditions, while loops allow a single exit condition and make the termination condition explicit. For this reason, we avoid break and prefer a single return at the end of a function. Again, this is a stylistic thing rather than a hard requirement. You'll find in a lot of languages, it sort of varies by language. When you're talking, I know I keep referring to C, but that's because I taught C last semester. When you're programming in a lower level language like C, much of the readability of your code is directly related to whether or not you follow conventions, because many of the things that are sort of enforced in Python are not enforced in C. They're sort of, you do it to be polite, if that makes sense. This is one of these things. This is a you do this to be polite kind of situation. It makes your code more readable, and that's a good thing. So anyway, that's topic 3. Do I have any questions? If not, I would like to get started very quickly on topic 4, since we have a little bit of time left. Okay. All right. On to talk. I hate it when I do that. On to topic 4. So, now we are going to talk about structured data types. Structured data types means data structures. So, up to this point, we have talked about strings and tuples. We are now going to expand our knowledge with 3 more data types. 3 more data structures. We're going to talk about lists, sets, and dictionaries. So, lists, first of all. Lists are very, 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 very similar to tuples. You index them in the same way. You create them in the same way. They have the same properties. Elements can occur multiple times. They do not have to be of the same type. They maintain their order. Once you put something in a list, it stays in the place you put it. The primary difference syntactically between, the only difference syntactically between lists and tuples is the use of square braces instead of round braces. So a list is declared with square braces and a tuple is declared with round braces. You will find that after this point in the course, most of the data structures that I use in this course, in lecture and otherwise, will be lists rather than tuples. So, the primary difference between lists and tuples is semantic, not syntactic, which is to say they're different in how they're used rather than how they appear. So, with a tuple, right, if we say tuple at index 3 is equal to 100, that does not work. That is an error. However, if we declare a list, and I'm just going to do the list version of the tuple. There we go. This is now a list. I have cast it as a list. If I say list at 3 is equal to 100, that is a valid operation. Notice that the 4th element, the element at index 3, has been replaced with the thing it's been assigned. So, in this sense, the elements of a list operate much more as you might expect a conventional variable to. Assignment operations work on the elements of a list, and that is the primary difference between tuples and lists. Cool. So, you'll notice, so here is a quick list of all of the operators that you will have over lists. This will be the last slide today. Lists are declared in the same manner, just using square braces. You can index them using list slicing, again, in the same manner as a tuple. So from 4 to 50 by 3s. There you go. Sure. Slicing works in the same way that strings and tuples are concatenated. Lists are also concatenated with the plus operator. You can take the length of them with the len function. There we go. You can test for membership. You can test to see if something is in a list. 60 in L? True. 160 in L? False. If you wish to repeat the list, you multiply it by an integer. There you go. And you can count the occurrences of something in L using count and find the first index of it using index. There you go. The takeaway from this is that all of the operations that you've already learned for tuples are, roughly speaking, applicable to lists directly. They mean the same thing when applied to a list as applied to a tuple. Again, the primary difference is that you can assign to a list, whereas you can't assign to a tuple. And we're going to see why and how and all of the rest of that next time in class. So, if there are any questions, please let me have those questions now. We shall have some questions, and otherwise I'll let you guys get along to whatever class it is that you guys have coming up next. Does everything in a tuple have to be the same element? No. So in a tuple, you can have mixed data types, which I think is what you're asking. So you could have 4, 5.9, the string, the world is round. Although that might be a controversial opinion these days. Yeah. So you can mix data types. And that also works inside of lists. So, you know, convert it to a list, and it still exists. In what circumstance would you use a tuple over a list? Good question, because I've made it sound a lot like lists are just more useful, and that is kind of true. So, the advantage that you get from using a tuple over a list is primarily a memory management one. So it's difficult to explain without getting into how the memory system of your computer works. But essentially, in your computer memory, think of your computer memory as being a series of boxes that get assigned to, like, they get filled with different things. When you are declaring a something like a tuple, one of your operating system's processes is to look through the memory for a slot that's big enough for the thing that you're trying to declare, and once it finds it, it fills it up with the thing that you're trying to put into memory there. The thing about a list is it's dynamic. So in a list, the amount of memory that it can occupy sort of grows and shrinks. So there's a lot of work that has to go on behind the scenes to keep moving it around memory into slots that fit that particular data structure. Whereas a tuple, once declared, will always occupy the amount of memory that it was declared with, so it doesn't have to be moved around after it's been declared. So that means that it's more memory efficient to use a tuple. That being said, it's again one of these kind of things where, from a functional perspective, it doesn't really matter that much. That level, like that type of efficiency, is not going to be something that you can see visibly unless you are, trying to do, several thousand operations per second for, there are applications where this type of thing matters. Like having efficient memory management matters. If you're trying to do applications like if you're writing an operating system, for instance, it matters. If you're writing a compiler, it matters. If you're doing server-related stuff, if your code is going to be executed several thousand times a second, it matters. Like, small inefficiencies will add up to big inefficiencies when you multiply them out over being run multiple times, right? So it does matter, but anybody who really cares about memory management isn't going to be using Python anyway. So, no, you'd be using something like C++, right? You'd be using something like C++ because C++ has a much more direct memory model. It doesn't, like, because Python is such a higher level language, it does all of this work in the background to keep, to keep you, the user, happy at the expense of the operating system, whereas C++ takes the approach, I'm going to keep the operating system happy at the expense of the user. So that's, roughly speaking, that's why you would use a tuple over a list. But for memory management issues, also, it's like the difference between having read-only and read and write privileges on a file, right? Sometimes you do want read-only privileges on a file, right? Sometimes that's useful. It's not often the case, but there are times when that's useful. But yeah, anyway, hopefully that answers your question. Okay, all right. Thank you very much, folks. See you on Thursday. Yay! Take her easy.